Welcome to Molecular Chaos, where science gets wacky.
Hey everyone, welcome back to Chaos with Kazi. Today we're talking about motion, and more specifically, Newton's first law of motion. And to explain it, I'm going to be using something simple but powerful. I brought you a marble run. This marble run is going to be a fun experiment today. The marble is the object we're observing, and the track lets us see how forces affect motion. Right now, the marble is sitting right at the top, completely still, guarded by this little door here. Until a force acts upon it as the slope going down into the run, it will not move. So Newton's first law says this: an object will stay still or keep moving in a straight line unless a force acts upon it. So this marble just won't move on its own until I open up this door. It needs force to start moving. And in this experiment, that force is gravity. When I let the marble go, it pulls downward and it starts rolling. Once it's moving, the marble wants to keep moving. And that resistance to the changing motion is called inertia. Let's do our first one. Woo. Inertia is why the marble does not just stop randomly in the middle of the track. If there's no other forces acting on the marble, it would just stop moving. But we see here we got this squiggly slope, we got a drop here and another squiggly slope and another drop. So why does the marble slow down and stop? It's because other forces are acting upon it, especially friction. And friction is the rubbing between the marble and the track as it pushes against the motion. On flat sections, gravity stops helping the marble move forward, and friction pushes back, and eventually the marble comes to a stop. This follows Newton's first law. The first law also explains why the marble turns. The marble does not choose to change direction, and the walls of the track apply as a force that pushes it to a new path. Without that force, the marble will keep moving straight. Let's put them down again. Woo. So this marble run shows Newton's first law perfectly. Objects will stay still or keep moving unless forces like gravity or friction or the track itself acts upon them. Every part of this track changes the motion by adding force. That's all for Chaos with Kazi today. Thank you very much for watching, and keep learning with me. Next up is Fun Facts with Jasmine.
Hey guys, welcome back to Fun Facts with Jasmine, where I tell you facts and obviously make it fun. Today, we'll be talking about Newton's second law of motion. There's an equation to help us remember this law. Force equals mass times acceleration. That means the mass of an object and the force pushing it determines how fast the object will actually move. Let me break it down for you. We've all used force before. Have you ever pushed a chair in at school? Squeezed a sponge? Or even pushed somebody on a swing? Congratulations! You've used force before. Fact number 1. Did you guys know Isaac Newton actually discovered gravity because of an apple? He saw an apple fall from a tree and wondered why things actually fall. This helps him explain gravity, the force that pulls everything to the ground. Some people say the apple fell on his head, which isn't true. I wonder what scientist started that rumor. Fact number 2. Isaac Newton worked for a king. He became a master of the Royal Mint, helping protect English money from counterfeiters. No fake bills on his watch. Fact number 3. Isaac Newton had a lab fire, which caused him to lose 20 years worth of research. The cause of that fire was his dog Timon at the time. I wonder what research was lost, and I wonder what inventions and discoveries we would have today. Now, back to the second law. So we know that force equals mass times acceleration. But what is mass? Mass is the amount of matter inside of everything, and everything is made up of matter. Think of mass like weight. Everything weighs a different amount. An elephant would have more mass than an ant. Even things close in size have different masses, like a basketball and a bowling ball. A basketball is way lighter than a bowling ball because it's filled with air. For instance, a bowling ball that is made from resin has a lot more mass. The last part of this law is acceleration. Acceleration means a change of speed or direction. Like when you're pedaling a bike and then you go downhill, you are accelerating. So now let's put this together in an example. If I had an empty cart, would it be easy or hard to push? That's right, easy. Good job, because the cart is light. Do you think we would go really fast or really slow? If you said really fast, give yourself a gold star. Now, what if I had an elephant in my cart? Do you think I would go really fast? No, that's right, because an elephant has a lot of mass. Oh, I guess it's time for another fact. Fact number 4. Isaac Newton loved building things from a young age. He built things like sundials, windmills, and even water clocks. Fact number 5. Newton helped invent a type of math called calculus. Calculus is a special type of math that scientists still use today to understand things that change over time. Fact number 6, Isaac Newton was knighted by a queen, which is why people actually call him Sir Isaac Newton. Well, that's all the time I have for today, guys. Thanks for tuning in to Fun Facts with Jasmine. See you next week.
Hey, welcome back to Molecular Chaos. This is Learning with Leslie. Today we're learning all about physics reactions. We've already learned about the first 2. Now we're going to learn about the third. Have you ever heard for every reaction there's an equal and opposite reaction? But do you know what that actually means? Here's some examples. When you push against something or pull against something, the forces are equal. So example, walking. You push your foot down on the ground and the ground pushes back. When I push against the table, the equal force is pushing back against me. A rocket ship is a great example of this. So the rocket takes off, the ignition pushes the ground, and it explodes into the sky. I'm sure everybody has thrown a ball against a wall and the ball has come back to them. That is the ball hitting the wall with an equal force that the wall is pushing back against the ball. Swimming and swinging, it's hard to say together, as well. It is really cool. So let's think about other things. Let's think about a case study. So when you think about a puncher, they practice punching with a punching bag that's full, it's heavy, and when they push it, it offers resistance. But do you think they could punch a tissue paper with the same force? No, because it doesn't have the same mass. So now we're going to take a look at my car here, and it winds up with an elastic, okay? And we're going to see how this works. We're going to wind it up, and the tires are going to push against the ground, and they're going to push off because the ground, or the table in this instance, is the equal force. Just give me 1 second. All right, I think we've wound it up enough. I'm going to hold on to it here. We're going to put the lid on, and we're going to count down, and we're going to hopefully see the reaction at work. Okay? 3, 2, 1. See how it's pushing? It didn't go very far, but it did go far. So the wheels are pushing against the table, and causing it to go forward with friction and with equal force. That is all I have today. When we come back, we will have more Marble Run.
Welcome back to Molecular Chaos. Before we go, here's a final look at science in action. I teamed up with other two hosts and we raced our marbles down the same track. And as you see, as you watch, if you can spot where the motion slows down and it changes direction, let us know. Let's roll to the video. All right, that's all for Molecular Chaos today. Bye, scientists.
Bye.
Bye.
I hope you come back next week.